All right, back for one more question. All right, this will try to sum up all the concepts we have learned. Okay, in setup A, one cell is connected to one light bulb, and the bulb is shining at normal brightness. This is one of those questions that they like to ask in the MCQ parts. Okay, right? If similar cells and light bulbs are used in setup B and C, describe the brightness of the bulbs. Okay, so these are good because I don't want you to think that what we have learned so far only works for resistors. In fact, every device has a certain level of resistance. So the rule of V equals to IR, Ohm's law, all right? And then the rules of potential difference behavior, current behaviors in other circuitry that has light bulbs other than resistors, they work the same, okay? So setup A, one cell, one bulb, normal brightness. So to help you, maybe let's assign a value. So let's say this is a 4-volt battery. Okay, so at 4-volt battery, the bulb is shining at normal brightness, means the bulb requires a PD of 4 volt to work properly. Okay, so in setup B, same cell. This requires 4 volt, this requires 4 volt. Okay, all right. Your instinct might tell you, since it is 2 light bulbs, it must be shining less bright. Okay, but you still remember about how potential difference behaves in a parallel circuit, different pathways. They are actually the same. So the PD across here, A, and the PD across B is the same. And since there's nothing else on the main path, all the EMF is committed to produce the same PD. Okay, so for setup B, PD across the bulbs is actually equals to the EMF. All right, so what you get is that you will get normal brightness. All right, okay, sounds interesting, but that is true. So what is the difference between setup A and B then? If you connect it in setup B manner, one cell powering 2 light bulbs in a parallel fashion, they will shine at normal brightness. But what's going to happen is that your battery is going to run out faster, okay, because it's doing both work to push 2 sides. So how do we get the same duration? So what you do is that you add another EMF, add another cell. But where do you place it? Because you still want 4 volts. So same thing. You place it parallel like this. Then you will have the 2 light bulbs running at the same time as this. Okay? You can't place it in series, because you place it in series, remember, the potential difference will add up. Then you will have a 8-volt EMF powering up 4-volt light bulbs. What's going to happen is it's going to boom, it might burst. All right? Okay? So that's for setup B. Let's see setup C. All right, part C. Okay? So this part gets a little bit more interesting, all right, because we have 3 light bulbs. Okay? So again, let's plug in some figures, and let's call this light bulb A, and this is B, and this is C. All right, okay, so the brightness of the light bulb is dependent on what is the potential difference across it. So we all know that in our case it requires at least 4, all right, for it to shine at normal brightness. Okay, so here the connection between A and this group of light bulb. Okay, so let's call this group maybe group D. Okay, all right, so A and group D, they are actually in series, right? And within group D itself, B and C, they are parallel. Okay, all right. Okay, I want to write this first so that we can quickly solve it. Okay, all right. So if A and group D, they are in series, it means that the EMF have to be shared. You have to split among these 2 groups. So whatever it is, it means that the potential difference across bulb A must be lesser than the EMF. So if that's the case, it will shine less brightly. Okay, right? So that's simple. Okay, then next is about these 2 bulbs. Okay, so these 2 bulbs, they are connected in parallel, and since they are similar bulbs, from our example B, we know that the PD across B and C, they are the same. all right? So that means they will also shine similar brightness. Okay, all right? Will they be able to shine at normal brightness compared to A? Definitely not, because in this case, the potential difference, some of the EMF is already taken by here, all right? So again, it is the same. It will be less than EMF, so it will be less bright, okay? But the question is, compared to A, would they be the same or would they be less bright, okay? So here you need to understand about calculating effective resistance. So remember what I tell you, that total resistance of resistors connected in parallel, it will be lower than the one that has the least resistance. So in this case, if this light bulb has a resistance of 4 ohms, then the combined resistance of this setup must be lesser than 4 ohms. All right? So if it is lesser than 4 ohms, it means that here, using V equals to IR, okay, the potential difference across here because of a lower resistance will be lesser compared to here, all right? So PD across B and C must be lesser than PD across A, all right? Means that it will shine at similar brightness, but less bright than A. Okay, all right. I know you might take a while to digest this, but take some time, think through, go through some of the concepts that I've taught you, and I believe you're going to get that distinction.